Hello and welcome to this new playlist, Machine Learning with Python, which is for absolute beginners. This is to help students and enthusiastic learners so that they can get a reasonably quick start to machine learning. There are plenty of resources on YouTube and other platforms on data science, coding, Python, machine learning, etc. In fact, learning data science related stuff is probably the easiest. Then why am I making this course? Well, the motivation is twofold. I want to reinforce my own understanding of machine learning algorithms while helping learners. Although there are plenty of resources on this, some are too comprehensive and lengthy, and the students generally give up midway. Some are too surface level, either focusing too much on a particular topic or just contain some jargon which are not practically helpful. Therefore, we need a pragmatic blend of theory with reasonable depth and drill that will show us firsthand how to implement that theory when we want to do machine learning or we want to learn machine learning, and hence this playlist. So let's see what we will learn in this course. We'll learn the scope of machine learning, meaning what kind of problems can be solved by machine learning. Basically, the problems can be categorized into two types, regression and classification. I'll shortly describe what they mean. In order to solve these types of problems, we need to learn some methods or algorithms, in this particular case, ML or machine learning algorithms. So let's be more specific. We can solve two kinds of problems with ML, regression and classification. By regression, I mean predicting something based on our algorithm. For example, let's say I have a bunch of data that shows a trend, meaning they can be fit with a particular curve or line. In this case, a linear trend. Then, if we want to predict a random value of y or dependent variable, if a corresponding x or independent variable is given, we can do that because we already know the trend. It's completely okay if some terminologies do not make sense at this point. I'll define them on the fly, meaning while working on practical datasets in the following lectures. The second type of problem is classification. Let's say I have, again, a bunch of data. If I plot them, I can see that there are some clusters or small subsets that are similar. So there are different classes in my data. If I can set some ground rules or criteria of classifying them, then we can guess what class or category any particular data should belong to. Sounds abstract? Well, within the next few lectures, they will start making sense. Now, let's see where we can implement ML or where it's being used. Basically everywhere nowadays, from engineering to medical science to day-to-day life to the internet. All of the technical fields use ML these days to facilitate solving problems. Some popular examples contain cancer research or spam email detection. Let's say you have a bunch of cancer patient data, several parameters. If you can analyze that data and run through a reasonable machine learning algorithm, you may be able to predict with reasonable margin of error which cancer patient is at benign stage or which one is malignant or advanced stage. So that's how we can go from abstract definitions to practical implementations. Let's come to the course content. To do ML with Python, we need several things. An interface for coding in Python, some libraries, some resources, and datasets, which we'll analyze by our code. So in the next lecture, we'll cover that, like how to set up Python, where to get resources and libraries for writing our Python codes, and where to get the datasets. And then we'll dive into regression theory. We'll start with the easiest regression algorithm, the linear regression. We'll first know what happens at the back end or under the hood, meaning how linear regression works. Then we'll implement that learning through some codes. In a similar manner, we'll learn more complicated yet popular ML algorithms and methods. Some methods require some additional theories so that we understand how the code is working. So we'll cover those in some lectures. Also, we need to learn some techniques and apply them to efficiently handle our data. Sometimes we'll require to evaluate the performance of our ML model and compare them by applying different algorithms. To the same dataset. Sometimes we need to compare them by applying different algorithms to the same dataset. Anyway, one by one, we'll learn some other methods and algorithms, such as decision tree, logistic regression, SVM, random forest, KNN, naive Bayes, vectorizers, k-means clustering, feature scaling, and so on. At the end, you should be able to implement different ML algorithms on your dataset and take decision on which algorithm is best for your dataset. However, as this is a fundamental level course, all the topics can be covered exhaustively. Certainly, we'll cover all the popular methods, and at the end, we'll mention some advanced level topics and strategy to make your way through the amazingly enriched jungle of ML documentation so that you can learn on your own. I'm really excited to share. Hope you'll stay tuned and provide feedback. See you in the next lecture. Thanks.